everyone, hope you all are doing great. In today's class, I'm gonna teach you grade 8 new book Ganita Prakash chapter number 1, a square and a cube. A square and a cube. Right, in first session I'm gonna explain every concept in detail. Right, just listen to it carefully, you will understand everything in detail. Right, let's get started. First one, what do you mean by square numbers? Okay, what do you mean by square numbers? A number obtained by multiplying a number by itself. It's called a square number. Okay, a number is obtained by multiplying a number by itself. A number is multiplied by itself. It's called as a square number. For example, a is multiplied by itself. A is equal to a square. It's a square number. For example, 1 square, 1 into 1, 1. 2 square, 2 into 2, 4. 3 square, 3 into 3, 9. 4 square, 4 into 4, 16. Okay, so 2 into 2. A number is multiplied by itself, it's given a square number. 9 is multiplied by itself, is giving 81. 81 is a square number. Hope it's clear. If the number is multiplied by itself, the number is called as a square number. Okay, now this is a definition for square number. Hope everyone is understood. Next one is perfect squares. Okay, what do you mean by perfect squares? Okay, perfect square is nothing but a square of a natural numbers. Okay, if you are taking the square for the natural numbers, you will be getting perfect squares. Okay, 1 square, 1. Okay, so before that you must know what is the natural number. Okay, natural number is starting from 1, 2, 3, 4, 5, 6, etc. If you are taking the square, 1 square is 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36. If you are taking the square of a natural numbers, you will be getting perfect square. Okay, now when we can say the given number is a perfect square, we know how to find out the prime factors. If you're finding the prime factors, right, so that should have the two identical group. Okay, two identical group. The prime factor can be split into two identical group. Then we can say the given number is a perfect square number. If it's not able to split into two identical group, it's not a perfect square number. Okay, for example, if you are just taking any example, I will just take 16. Okay, for the 16, if I want to find the prime factor of 16, right, what are the prime factors of 16 we will be finding out. So we will be doing the prime factorization, right? So prime factorization, we will be using only the prime numbers. Okay, 2, 3, 5, 7, 11. Okay, first you can go with 2 table. Okay, 8 2s are 16. Next, if I take 2 table again, 4 2s are 8. Again I can take 2 table, right, 2 2s are 4. Next again I can take 2 table, 2 1s are 2. That means 16 can be written as, so 2 into 2 into 2 into 2. Okay, this is can be split into two identical group. This is having a pair, this is also having a pair. Therefore 16 is a perfect square number. If it doesn't have a pair, or if we will not able to make it as a two identical pair, so it's not a perfect square number. You can check it for other numbers. It can be split into two identical group. It's a perfect square number. Otherwise, it's not a perfect square number. Okay, 16 is a perfect square number. Right, so visualization of a square numbers. Okay, why the name is given as squares? Right, so you can just see everywhere square. Okay, only one square is forming a square. Okay, 2 square. Okay, 4 small square is forming a square. 3 square, 9 small squares with 1 unit is forming a square. Okay, 4 square, 5 square, 6 square. Everywhere you can just see the shape of squares. That's why it's called as square numbers. Right? Now, in your level, at least you must know the square numbers from 1 to 30. Right? You have to memorize. Okay, you have to understand and learn at least 1 to 30 squares. 1 to 10 squares everyone know by seeing the table. Okay, 11 to 20 you have to learn, right? For learning 11 square 121, 12 square 144, 13 square 169, 14 square 196, 15 square 225, 16 square 256. Okay, up to this somehow you learn. For getting 17, 18 and 19, some of you will get doubt. Even I had a doubt how to get the answer. The shortcut is, right? So we know the unit digits. 1 is ending with 1. 2 square it will be ending with 4. 3 square it will be ending with 9. 4 square is ending with 6. 5 square is ending with 5. So you must know all the ending digits. Okay, if you know 1 to 10 square, we know what is the ending digits. The same concept for 11 to 20 also we can easily find out the ending digits. 21 to 30 also we can find out the ending digits. Okay, I'll just give small shortcut for finding 17, 18, 19 square. So we are just going to use, right, 4 table. Okay, so for getting first 2 digit alone, if you are using 4 table, just multiply by 4. Okay, 7 fours are 28. The unit digits, the 7 square unit digit is ending with 9. So 9. 8 into 4. Okay, 8 fours are 32. The unit digit should be ending with 4. Okay, why? Because 8 square is ending with 4. So unit digit is 4. 9 square. Okay, unit digit is 1. Okay, 9 into 4. 36. First two digits by multiplying by 4, you will be getting first 2 digits. The last digit we will easily identify by the unit place. Okay, the last digit. So like this you have to learn 21 square to 30 squares. Okay, if you are learning 1 to 30 squares, then right, you can easily, whenever we need the numbers or square numbers, if you want to take the square root of the number, we can easily identify. Right. Now, so unit digits rules. Okay, this is very important. Okay, unit digit is nothing but the last digits, ending digits. The perfect squares can end only in 0, 1, 4, 5, 6, 9. That means you have to remember this. Okay, the perfect square numbers never end in 2, 3, 7, 8. Okay, instead of remembering this, you can remember this. Perfect square number should not end with 2, 3, 7, 8. Okay, you can just see any square number is ending with 2, 3, 7, 8. No. Okay, perfect square number, okay, never end with 2, 3, 7, 8. 2, 3, 7, 8. You have to remember this. Okay, once again, perfect square number does not end with 2, 3, 7, 8. Now, okay, small activity. Okay, find the square numbers between them. Okay, find the square numbers between them. So, between them. So, 1 to 100. Okay, 1 to 100, how many square numbers? So, they have asked between them. That means we should not include 1 and 100. Okay, so between means you should not include 1 and 100. Okay, 1 to 100, how many square numbers? Okay, 1, 2, 3, 4, 5, 6, 7, 8. So we'll be having 8 square numbers. Correct. The same is 101 to 200. 101 to 200, how many numbers? Okay, 1, 2, 3, 4. Okay, we are having 4 numbers, correct? So like this you can just fill it up the balance. Okay, up to 1000. Okay, 900 we know. Okay, just you can just expand up to 1000, then you can find out. Okay, you can just easily fill up this dash. These are small activities you can just try by yourself. The next one, okay, the numbers having unit digits. Okay, if the number is having 0 at the unit digits, the square is ending with 0. If the number is having 1 or 9 in the unit digits, the square number is ending with 1. If the number is having 2 or 8, the squares ends in 4. The number is having 3 or 7, okay, the squares is ending in 9. 4 or 6, it will be ending with 6. 5 means it will be ending with 5. 0 is ending with 0. 5 is ending with 5. 1 and 9. For example, 1 square is ending with 1. 9 square. 9 square is 81, ending with 1. 2 square, 4. 8 square is 64, ending with 4. 3 square, 9. 7 square, 49. 4 square, 16. 6 square, 36. Okay, ending with 6. Right, this will help us to find out the ending digits or unit digits. Okay, keep remember all these things. Right, I have just given only the important concept for solving the first. Figure it out, right? For entire concept you can just easily understand. The next one, if a number ends in 0, 1, 4, 5, 6 or 9, is it always a square number? We have learned here. Okay, here I have given the square number can ends in, okay, the square numbers can ends only 0, 1, 4, 5, 6, 9. Now the question is, the number is ending with these digits, that should be a perfect square number. What is your answer? Actually the answer is, it can be or cannot be a perfect square number. Definitely we cannot say the number is ending with 0, it's a perfect square number. Okay, why? Because we are just taking and number is 10. Okay, 10 is ending with 0, is it a perfect square number? No. 11 is ending with 1, is it a perfect square number? No. 24 ending with 4, is it a perfect square number? No. 55 is ending with 5, is it a perfect square number? No. 66, okay, or 39, are these numbers a perfect square number? The answer is no. Okay, here what they are trying to say means, right, the square numbers can end only in this. They are not telling that it must end with this, but this one, okay, it's compulsory. We can just say that the square number never end in 2, 3, 7, 8. Okay, the square number can end with these numbers but cannot end with these numbers. Okay, that's only they have asked a question in the form of, okay, if a number end in 0, 1, 4, 5, 6, 9, is it always a square? The answer is no. Okay, the number 26 whose unit digit is 6, but it's not a square number. Okay, I have given many examples. Okay, it's not necessary if the number is ending with this, it should be a perfect square number. It can be or it cannot be. Hope understood? Now, so which of the following numbers have the unit digit 6 in the unit place? Okay, which of the following numbers have the unit digit 6 in the unit place? We have to check. For checking this, we no need to take 38 square mean 38 into 38. No need to do that. Just take the last digit. 8. 8 square is 64. Okay, is ending with 4. That means this is not. It's not ending with 6. 34. 4 square is 4 4s are 16. 16. Right? So ending with 6. 6 square 36. So it's ending with 6. 56 ending with 6 square is 36 ending with 6. 74. Okay, 4 4s are 16 ending with 6. 2 square 2 2s are 4. So it's not ending with 6. So check the last digit and take the square and check. We will find the unit digits of the given number. Right? The next one, okay, zero rules. If a number has n zeros, then its square has 2n zeros. If the number has n zeros, then its square has 2n zeros. For example, if the number is having 1 0, okay, the square is having 2n zeros. Okay, 1 0 means 2 into 1 is, you will be having 2 0. Now, if the number is having 2 zeros, so 2 into 2 will be having 4 zeros. Okay, will be having, it will become double. The number is having only n 0, then square it will be having 2n zeros. Okay, 1 0 means it will become, okay, multiply by 2 it will become 2. Okay, 2 zeros double, it will become 4 zeros. Next, a squares always have even number of zeros. Okay, squares always having even number of zeros. Okay, either 2 0 or 4 zeros. This is square. Okay, square number is having only even number of zeros, 2 0, 4 zeros, 6 zeros, 8 zeros. Okay, it cannot have odd number of zeros. Okay, a square always having even number of zeros. The next one is perfect square and odd numbers. What is the connection between perfect square and odd numbers? Okay, adding consecutive odd numbers starting from 1 gives a consecutive square numbers. Okay, if you are adding consecutive odd numbers 1 3 5 7 9 11. Okay, consecutive means next number. Okay, continuous number. If you are adding starting from 1, it will gives the square numbers. We can check 1 1. Okay, 1 plus 3 4 square number. 1 plus 3 plus 5 9. 9 is a square number. 1 plus 3 plus 5 plus 7 16 is giving a square number. 1 plus 3 plus 5 plus 7 plus 9 plus 11 36. 36 is a square number. So clear? Adding consecutive odd numbers starting from 1 gives consecutive square numbers. Okay, this is one of the notes. You can make a note of it. The next one is perfect squares and triangular numbers. What is the connection between perfect squares and triangular numbers? Right, so triangular numbers, you can just see the triangle formation here. 1 dot, 3 dots, 6 dot, 10 dots, 15 dots. How we are forming the triangular number? For getting the triangular number, right, I have given the formula, that is n into n plus 1 by 2. If you are applying the values here in the formula, you will be getting a triangular number. For example, if I take n is equal to 1. Okay, if I take n is equal to 1, I will be getting first triangular number 1 into 1 plus 1 divided by 2. What will I get? So 1, okay, into 1 into 1 plus 1 is 2. So divided by 2. We can just simplify 2 to get cancel 1. We are getting first triangular number. Next, if I take n is equal to 2, what will I get? 2 into 2 plus 1. So divided by right? So what will come? So 2 into 2 plus 1 is 3 by 2. So 2 to get cancelled, I am getting 3. 3. Next triangular number is 3. Next, if I take n is equal to 3, you will be getting 6. N is equal to 4, you will be getting 10, 15, okay, and so on. So like this, you can find the triangular numbers. Now, so what is the connection between triangular numbers and perfect squares? Okay, here is given that sum of two consecutive triangular numbers is a perfect square. Sum of two consecutive triangular numbers. Okay, if you are adding sum of two consecutive triangular numbers, it will form a perfect square number. 1 plus 3, 4 is a perfect square number. 3 plus 6, 9, it's forming perfect square number. 6 plus 10, 16 is a perfect square number. 10 plus 15, 25 is a perfect square number. Okay, sum of two consecutive triangular numbers is form a perfect square number. Okay, right. Next one is a sum of odd numbers. Okay, if you are adding odd numbers, right, 1, 1 square, 1 plus 3, right, is equal to 4. 4 can be written as 2 square. 1 plus 3 plus 5. Okay, the same thing in a before slide we have seen, right? 1 plus 3 plus 5, okay, is equal to 9, 3 square. From this, what we are understanding it, right? So if they are giving 1 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus, so keep on going like this. We no need to add everything. Okay, from this we are going to derive one small formula, right? We no need to add everything. Just find out how many digits. Okay, here only one digits, 1 square. Here how many digits? 2 digits, so 2 square. 3 digit, 3 square. 4 digit, 4 square. The same as, right? The formula is sum of first n odd numbers is equal to n square. Okay, we no need to add everything. Instead of adding 1 plus 3 plus 5 plus 7, okay, just count 1, 2, 3, 4. 4 square, so 4 square will be writing as 16. Directly we can write. The same as if you want to write 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. If you are adding one by one, it will take time. You know, instead of adding, you can just count how many digits. 1, 2, 3, 4, 5, 6, 7, 8. So 8 square. Okay, 8 square is 64. Okay, like this you can just directly get the answer. The next concept is, right, there are 2n non-square numbers between the square of any two numbers. Okay, there are 2n non-square numbers between the square of, okay, n and n plus 1. That is a consecutive numbers. Okay, so this is also one important concept. There are 2n non-square numbers between the square of n and n plus 1. For example, how many non-square numbers in between 1 and 1 square and 2 square? 1 square and 2 square in between how many non-square numbers? Okay, so in between what are the numbers will come? 1 square is 1, 2 square is 4. In between we have 2 and 3. Okay, 2 and 3. So we have only two numbers. Okay, we have only two numbers. Okay, two non-square numbers between the two square numbers 1 and 4. This is very simple. Suppose if they are asking, okay, how many non-square numbers between 4 square and 5 square? 4 square is 16, 5 square is 25. Okay, in between how many numbers is come? We no need to count. So after 4, 16 means 17, 18, 19, 20, 21, 22, 23, 24. Right, small number you can count. If it's a big number, we no need to count and check. So the formula is 2n non-square numbers. n is nothing but the first value. N is nothing but the first value. So directly we can multiply. So 2 into 4. 2 fours are 8. There are 8 non-square numbers between 4 square and 5 square. Now can you tell me how many square non-square numbers between 7 square and 8 square? 7 square and 8 square means, right? 7 square and 8 square. We no need to check. So this is n value. So 2 into 7. 2 sevens are 14. So we'll be having 14 non-square numbers in between 7 square and 8 square. Okay, these all are very important concepts, right? So keep understand and learn. This will help you while doing the problem. Next one is a square test. A square test for odd number subtraction. Okay, this is called as repeated subtraction. Okay, so to check whether the given number is a square number or not, we will be having this one of the method, that is repeated subtraction method. Okay, so repeatedly subtract the odd numbers 1, 3, 5, 7. If the result becomes 0, it's a perfect square number. If it's not 0, it's not a perfect square number. Okay, this is one of the tests to check whether the given number is a perfect square or not. For example, I have taken 64. I have to check 64 is a perfect square or not. So I have to keep subtracting odd numbers starting from 1. 64 minus 1, 63. 63 minus 3, 60. 60 minus 5, 55. So keep subtracting the odd numbers. In which stage you are getting 0? Okay, I am getting in 8th stage. In 8th stage I am getting 15 minus 15 is equal to 0. Therefore, the square root of 64. Okay, therefore the square root of 64 is equal to 8. Okay, that means we can say another way 64 is a perfect a square number. Okay, square root I will be teaching now. From this you can just say that 64 is a perfect square number. Why? Because, right, so the result become 0. Hope you all are understood.